this when I can't even see how it could have happened. That's blind faith.
That's a leap in the dark.
That's a leap in the dark.
It seemed that everywhere I looked, there was a growing body of evidence that fit the historical record of Genesis. It wasn't just one thing, it was many things pointing in the same direction. When I was with Art, he told me about some recent discoveries of material inside dinosaur bones. So I traveled to a lab in Arizona to talk to a scientist who is doing some of that research himself.
This is a fragment of a Triceratops horn. When we pulled it out of the ground, it fragmented, and then, of course, we've had to continue to fragment it in order to do analysis of it. In 2012, the Creation Research Society sponsored Mark Armitage and I to go to the Hell Creek Formation in Montana, which is a very popular place for finding dinosaur bones, and we instead dug out a almost 4-foot-long Triceratops brow horn. Now, it's just in crumbled pieces now, so we can't really, put it together and show you a horn. But yeah, you have to recognize that pieces such as this, we have found tissue with cells.
Oh, that's amazing.
And potentially proteins such as collagen. It's so difficult to understand how you could have this material still in a dinosaur fossil that is supposed to be 65, 75, 80 million years of age, because tissue, cells, proteins break down. They're not concrete, they don't just exist for eons of time, they break down. And in fact, they tend to break down fairly quickly depending upon the conditions. And certainly in Hell Creek, the conditions would be warm up, cool down, warm up, cool down. And any biochemist can tell you that is the fastest way to destroy material. It's difficult enough to envision it surviving for 4,000 or 5,000 years, but 60 million years, 70 million years, see, that really becomes very difficult to make any kind of biochemical basis for how it could have survived.
Okay, so once you find a sample like this, what do you do next?
So what we do is we soak the fossil material in a solution called EDTA. And what you'll have after you dissolve the fossil is the tissue will be remaining because the EDTA won't dissolve the tissue. So then I'll bring this over to what we call a dissection microscope. This is, in essence, dissolved Triceratops horn magnified. And so you can see what it looks like, just kind of little pieces of rock.
Well, Kevin, what did you find then when you were looking at the sample and you actually found some tissue?
Okay, here's what we found. This is actually Triceratops tissue. It's stretchable, it's pliable, it's not an impression of the soft parts of the dinosaur. This is truly soft, it is squishy, it is stretchable, it is tissue.
That blows your mind, huh?
Absolutely. And if you look at them then at a closer magnification, what we see then, this is using scanning electron microscopy, you see the extreme detail of the cells. See, in that picture, and this picture, and particularly like look at this picture, we would not begin to expect to see such enormous and elaborate detail. I mean, these structures are incredibly small. This is our 20 micron bar here. See how small these structures are, still intact. It would take very little to break those. So at best, you would expect that all that would have broken off and been long gone.
So that has to have shaken up the scientific community. What's been the response of all of this?
The initial response, when Dr. Schweitzer first published her work, which is what became very popularized in 2005, it generated a lot of response. And so initially, some of the reaction was rejection. Oh, it's contamination. That's not really dinosaur. It's bacteria, because bacteria can look kind of strange sometimes. So you had a lot of proposals of what it could be. And to her credit, Dr. Schweitzer did more work. They began to find protein. You break open some of these cells. You look at the matrix these cells are attached to, and they're protein.
Okay, so once that is understood,
Yes.
then what happens? Now, this is shaking it up, I guess.
That becomes part of the controversy, because clearly you're now faced with how could you explain the survival of this, the pristine survival of this, not only for so long, but in very unpristine conditions. And so then the controversy has been, how do you explain it? And if you read some of the literature, there's almost like desperation because they recognized what the implications of this could be. Now, some people would claim, well, it means nothing because we know how old they are, and therefore it just means it survived somehow, big deal. But how do you know how old they are? Well, you used methods, supposed methods of dating. Well, this is a method of dating. The tissue itself can't be discounted as part of a method of dating. So why do you say that doesn't count, but this does count? Well, it's all the paradigm drives your conclusions. The paradigm is it has to be old. Therefore, methods that give us an old fossil are what we choose. Something that doesn't give us an old fossil, like tissue, we have to reject or explain away.
At least to me, and of course, I'm not a microbiologist, but I think most people would say, well, that just seems reasonable to think that maybe these are not that old.
Clearly, this is in violation of the dating process. It challenges the entire dating process. If the fossils of dinosaurs have been dated incorrectly, which I would say this is clear evidence they have, then it's very likely the fossils of any organism have been dated incorrectly, and therefore then the geologic ages themselves are incorrect.
What you're saying is that if you pull out the notion of a long period of time, you're pulling out a major foundation for the conventional paradigm.
Absolutely. In fact, time is the critical component for evolution. If you're going to say that a simple cellular system became a multicellular system that then became fish, and the fish then jumped up on land and grew legs and started breathing air, and then that creature grew feathers and wings and started flying. So if you give us time, we'll claim to account for all of this massive change of organisms, but we got to have the time.
Everything seemed to come back to the question of time. I remembered Andrew saying that Charles Darwin accepted millions of years first, then fit his theory of evolution to that assumption. But why is time such an important element to evolution?